Hello, this is Farhan Shakil from the Republic 2.0, and here I am, back with the part 3 of the 16th May 24 Edexcel exam of AS level 3 GCE. So, in the previous two videos, I've already recorded the first 9 chapters, if I'm not wrong, 9 questions, if I'm not wrong. So, in this paper, we'll restart from the question number 10 on your screen. And question number 10 is that you've got a straight line, then you've got a circle. The figure shows a sketch of the circle. The point P, the center of the circle, is -1 and k plus 8. And the point Q is 3 and k square minus 2k lies on the C. K is a positive constant. Line L is a tangent to C at Q, and the gradient of line L is -2. So we both know that uh, the line, this PQ, is perpendicular to the line, the tangential line. So if the slope of the gradient of the tangent line is -2, the gradient of PQ has to be the negative reciprocal of it, and that comes out to be 1 by 2. So for the A part, slope of PQ is already given, and we can write it to be equal to 1 by 2, and that is what we need to do, right? So we have got the gradient, and that gradient comes out to be 2. And apart from that, we also got both the points P and Q as well. So I'm just going to use both of these points. You've got k square minus 2k minus k minus 8. That is the change in y. So I will have k square minus 2k minus k minus 8 divided by x2 minus x1. x2 is 3 and x1 is -1. So you just need to add -1 into it and you'll have -1. We're going to keep it equal to 1 by 2. And after solving it down, I would be having k square minus 3k minus 8 divided by 4 equals to 1 by 2. So by solving it further, I would end up having k square minus 3k minus 8 is equals to 4 by 2, which is going to be 2. And the end equation would be k square minus 3k minus 6 is equals to 0. So that is what I already got, right? Sorry, it has to be negative, 2. It should be -10. Sorry. So you've got k square minus 3k minus 10 for the A part. In the B part, we need to find the equation of C. So how can we find out the equation of C once we have got P and Q? P is the center and the distance PQ should be the radius. So first of all, let's get yourself K. So in the B part, I've got the equation which says k square minus 3k plus 10 is equals to 0. It can also be written as K. You'll be having k -5 times k positive 2 equals to 0. So the value of k that we would be having is 5 and -2. But in the question, they told us that k is a positive constant. If k is a positive constant, so now the coordinates of P are going to be the center -1k plus 8, yani it is going to be -1 and 13. And the coordinates of Q are going to be, if you remember, Q was 3 and k square minus 2k. So 3 comes as it is, and k square, 25 minus 2 times 5 is going to be 50. So you will have P and Q. And after having P and Q, you can easily get that radius by just calculating the PQ distance. And you would end up having 3 minus -1 ka square plus 15 minus 13 ka square. And at the end of the day, you would be having 4 square, which is 16, right? 4 square, which is going to be 16, and it is going to be 4. So you would have something like root of 20, and this root of 20 can be further written as 2 root of 5. That is going to be PQ. So now, equation of circle is going to be, I'm just going to plug these values in the original form. X minus a is -1, plus y minus b is 13 square, equals to the square of the radius, and that is 2 root of 5 ka square. So I'm just going to calculate this thingy now, and I'll having x plus 1 ka square plus y minus 13 ka square equals to the square of 2 root of 5 is going to be 20. So that is the required equation of circle. Now we'll get to the next question. and that is question number 11. The prices of two precious metals are being monitored. The price per gram of metal A is VA pounds, is modeled by the equation this thingy, where T is the number of months after monitoring began. The price per gram of another metal is something like this, where P is a positive constant and T is the time of months after monitoring began. Given that VB is equals to 2VA when T is equal to 0, find the value of P. So that's very easy. For the A part, we just need to use according to the given condition. So according to the given condition, VB 2V, right? That was A when T is equals to 0. So I'm just going to write down the VB value. The VB was P E negative 0.02 times T is equals to 2 times VA. What was VA? V according according to the given condition, according to the given condition, dVA upon dt must be equal to d. They both must be equal. Now we're just going to differentiate that thing d upon dt. If you remember, the v was 100 plus 20 40 thingy was d upon dt. Vb was P was 240 now, 240 e to the power of negative 0.02 into t. It has to be 0, 20, right? 20 times the differentiation of 0.0 times e to the t as it is. E to the power of negative 0.0 t. That is going to be the simple. Now when you're going to solve it down, you would be having something like, because you just need to move e together. And if you're going to move e together, you would be having 20 times 0.04 is something like 0.8. It is going to be 0.8 e to the power of 0.04 t. E's together, bring this e here. So you will be having 0.4 t divided by e to the 0.02 t is equals to, it has to is equal to e to the not for this, and now by just taking log on both the sides, I would be having 0.0 log e is equals to x. You know, the cap. how we're going to get our T. So that was question number 11. Now we'll get to 12. And the question number 12 says that you have got a pool, which is a semicircle, which is a quarter of a circle, and two, right? We have got these two thingies, and we have got two equal rectangles. And this has to be x, this has to be x as well, this has to be y, and this has to be y. Why? Because if you read the question, figure 5 shows a plan view for a design of a swimming pool. The pool is modeled as a quarter of a circle joined to two equal sized rectangles. As shown that, given that quarter of circle rectangle, the total surface area of the swimming pool is 100 meters squares, right? Show that according to the model, the perimeter of the swimming pool is given by 2x plus 200 upon x. So first of all, if you talk about it, it is given, if I write it down, it is given in the question that total surface area of the swimming pool is 100 meters square. And how would you get yourself the total surface area? You can get yourself the total surface area by just adding up the areas of all these things, right? If you remember, you had two rectangles, right? Area of one would be xy, the other one would be xy, plus the area of the quarter of circle is going to be 1 by 4 of pi r square. And the radius, if you remember, the radius was x, right? So it would be 1 by 4 pi x square is equals to 100. Plus now this equation can also be written as 2xy plus 1 by 4 pi x square equals to 100. That is equation number 1. But now if I write an equation for the perimeter of circle, if a perimeter of this thingy, you can see that you have got this side, you have got this side, x and y, then you have got another y, so 2y it becomes, then you got another x, then you got another y, another y. So how many y's we have got? 1, 2, 3, and 4. How many x's we have got? 1 and 2, right? And how would we get the circumference or the perimeter of this? This should be the quarter of the perimeter. That has to be something like 1 by 2 pi x, right? So we're just going to add them up and we'll write an equation for the perimeter. So the perimeter is going to be, if you remember, we had 4 y's. So it would be 4y, 2 sides x, and plus pi by 2 of x, right? So we have got this equation as a perimeter. Now the thing is that, uh, you know, we need to have an equation by eliminating y, right? So get yourself the value of y from this equation, the equation number 1, and plug it in the second one and just solve it out, right? So from equation number 1, it can be seen that, first of all, I'm just going to multiply every side by 8. So I would be having, 8 times, well, if, we can multiply it by 4 as well. 4 times 2 has to be 8xy plus pi x square, and 4 times 100 is going to be 400, right? And then y would be 400 minus pi x square divided by 8x. That is how we can get the value of y. Now just plug that value of y into this equation and sort it out. So you would have perimeter is equals to 4 times 400 minus pi x square divided by 8x plus 2x plus pi by 2x. So now I'm just going to solve it down, and I would have 4 ones are 4 twos are. So I would be having, 460 upon 2x, yani 400 upon 2x, that is going to be 200 upon x minus pi by 2 x square, right? Minus pi by 2 x square plus 2x plus pi by 2x, right? I'll be having something like this, right? Something like this. This and this gonna cancels out, and you'll be having pi by 2x, and this is pi by 2x. Cancel them up, and you would have the perimeter. The expression for the perimeter is going to be 200 divided by x plus 2x. That is an expression for the perimeter. Now in the B part of the same question, use calculus to find the value of x for which the p has a stationary value. How would we get the stationary value? We just need to get ourselves the first derivative of this equation. So for the b part, p is basically 200 x to the power of -1 plus 2x. I'm just going to differentiate it now, and I would be having dp upon dx equals to -200 x to the power of -2 plus 2, right? And I would end up having dp divided by dx equals to -200 divided by x square plus 2. Now, since I need the value of x, so I'm just going to plug in dp upon dx equals to 0 because I'm looking for the stationary point. And I would be having -200 divided by x square plus 2. So moving this -200 upon x square to this side, and you would have 200 divided by x square equals to 2. Reciprocate both the sides, and you would end up having x square equals to 200 times 2 has to be 400, right? Not 400, sorry. You have to reciprocate them up. X square upon 200 equals to 1 by 2, and x square would come out to be 100, and x should be plus minus 10. So that is how we got ourselves the value of x for which it has a stationary point. Now after this thingy, we need to prove in this in the C part, prove by further calculus that this value of x gives a minimum value for the p. So, to calculate that whether it is a minimum or a maximum, we need to calculate the second derivative. So for the C part, d square p upon dx square is going to be, if you remember, this was the first derivative, right? So the second derivative is going to be 400 and then x to the power of -3. 400 x to the power of -3, right? Or you can just simply write it 400 divided by x cube. So I'm just going to solve it down, and I'll be having d square p dx square 400 divided by 10 cube, and I would be having something like 0.4, which is greater than 0. So it is a minimum at p is equals to 10 because the second derivative is greater than 0. Now for the last part, uh, access to the pool is by the side AB shown in the figure 5, right? Given that AB must be at least 1 meter, determine according to the model whether the swimming pool with the minimum perimeter would be suitable. Well, we just saw that the minimum, the length of the perimeter can be 10. So what does that mean? That 1 meter is going to be suitable, right? Because we've got 10, so 1 meter should be suitable as well. So you just need to write that down in a single line. Now you've got this question number 13, and in question number 13, we've got this equation. Show that the equation sine theta times 7 sine theta minus 4 cos theta is equals to 4 can be written as 3 tangent square theta minus 4 tangent theta minus 4 is equals to 0. So we just need to work it out. So if you want to work it out, you've got the A part. Just grab the equation. Sine theta times 7 sine theta times minus 4 cos theta is equals to 4. And we need to write this equation in terms of tangent theta. So what I'm going to do, I'm just going to try to make all of these equations look like tangent theta first of all, right? So what I'm going to do, I'm just going to multiply them up, and I would be having 7 sine square theta minus 4 sine theta times cos theta is equals to 4. Now, since I need tangent square theta, and if you look into the proof, I need tangent square theta and then tangent theta and then blah, blah, blah. So what I'm going to do, I'm just going to divide all of these equations by cos square theta, and I'll see what I'll be having. So 7 sine square theta divided by cos square theta minus 4 sine theta times cos theta divided by cos square theta is equals to 4 divided by cos square theta. Now I'm just going to sort it down. This would become 7 tangent square theta, right? And then negative. This and this would cancel out, and I would be having 4 tangent theta. And over here, I would be having 4 times cos square theta, right? I would be having 4 times 4 upon cos square theta. And once I've got 4 upon cos square theta, everybody should know that we can write this, cos square theta, we can write this cos square theta to look like 4 times sine square theta plus cos square theta, which is already 1, divided by cos square theta, right? And the other term as it is. So I would be having 7 tangent square theta minus 4 tangent theta is equals to, 4 sine over cos square theta has to be 4 tangent square theta. And then cos, it should be just 4. Got it? Now I'm just going to move this tangent square theta over here, and I would be having 3 tangent square theta minus 4 tangent theta, and then negative 4 equals to 0, which was equal to the equation that we needed to prove. Now in the B part, from T0 to 360, we need to solve this equation down. And this equation, we have already got this equation in the form of this thingy, right? So we just need to use the quadratic formula to get ourselves the values of theta. So for the B part, since we both know that sine theta times 7 sine theta minus 4 cos theta is equals to 4. It is also can be written as 3 tangent square theta minus 4 tangent theta minus 4 equals to 0. So by applying the quadratic formula, your A is going to be 3, your B is going to be negative 4, your C is going to be negative 4. So by just applying the quadratic formula, you can get yourself the values of thetas, and the values of theta is going to be, for example, when the theta would be positive, it would be 63.4 and 243.4. And when the theta is negative, it is going to be 146.6 and 326.6. You can use the quadrantal mensurations to get these values, right? So these are the values of theta 1 in the B part, right? In the C part, hence find the smallest solution of the equation sine 4 theta times sine 7 sine 4 theta minus 4 cos 4 theta is equals to 4. So what does that mean? That you've got this range, and which is alpha. So 4 alpha is going to be in between. If I just write it down, I had a range of alpha from 720 to 1080, if I'm not wrong, right? Let me just see that. Uh, 720 and 1080. Yep. So you've got 7,000 and 1080. But if you remember the equation now we're looking for is not in terms of alpha, it is in terms of 4 alpha. So I'm just going to write it down, and I would be having, sine 4 alpha times 7 sine 4 alpha minus 4 cos alpha 4 alpha and is equals to 4. So the thing is that this limitations would change, and this limitation would change 4 alpha. And now the limits should be, 4 times 720 is going to be 2880 degrees, and 4 times 1080 is going to be 4320, right? So the angle that we would be having, we can see that the shortest angle was 63.4. So just add, you can just simply, add 63 into this thingy. And when you're going to add 63.4 into this thingy, because that is the smallest angle. So 4 alpha 1, the smallest angle that we are looking for would become, 2880 plus 63, it should be 2993.4 degrees. But we're not looking for 4 alpha, we're looking for alpha 1. So alpha 1 has to be 2993.4 divided by 4, and that's going to give you 735.9 degrees. So that is how you can get yourself these angles. Okay. And that was the smallest angle we're looking for. So we're done with the C part, and now we have got this D part. Yep. Prove using algebra that n square plus 5n is even for all the n. For example, natural numbers could either be even or odd. For odd, we can assume that n is going to be 2m plus 1. Let's plug it in and see what it gives us. So 2m plus 1 ka square plus 5 times 2m plus 1, expanding it down, and I would be having 4m square plus 1 plus 4m plus 10m plus 5. So by just sorting it out, I would be having 4m square plus 14m plus 6, which is basically 2 times 2m square plus 7m plus 3, which is an even number because it is a multiple of 2. Now, for another natural number, for even, you need to assume that n is going to be 2m, right? So plugging that value, you'll be having 2m ka square plus 5 times 2m, and I would be having 4m square plus 10m. Now you can see that 2 can be granted as common from both these terms as well, and I would have 2m times 2m plus 5, and that is going to be the answer we are looking for. Is that clear? So that was the latest paper of Pearson Edexcel, Local England, Pure 1. I hope you've got every question. If you've got any questions regarding any of these three videos, you can just post your questions in the comments. I'll try to respond as soon. Thank you very much.